Hello and welcome back. Today we are discussing the second practice problem on DP. This problem is quite similar to the first practice problem with minor differences. So let's quickly go through the problem statement. So it states that you're given an integer array cost, where cost of I is the cost of ith step on staircase. Once you pay the cost, you can either climb one or two steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top of the floor. Now let's first start by discussing the recursive solution for this problem. So if I'm at step x and let's say that the cost for step x is y. Now from step x I can jump to a step x plus 1 or I can jump to a step x plus 2. And now let's say that this is the end. And let's say that we have the cost of going from x plus 1 to the end and we also have the cost for going from x plus 2 to the end. Let's say that the cost of climbing the whole staircase from x plus 1 is a and the cost of going from x plus 2 to the end is b. Now, if we have already been given these costs A and B, it will be really easy to decide that whether I need to jump to x plus 1 or x plus 2. I can simply compare A and B and decide which step I need to take because cost of going from x to x plus 1 and then to the end will be A plus y and cost of going from x to x plus 2 and then to the end will be B plus y. So we are in any case paying y cost. So if a is greater than b, that simply implies that I should jump to x2 and then move to the end. If it is the other way around and b is greater than a, then that simply implies that it would be profitable to pay y and jump to x plus 1 and then move to the end. Now the only problem is that we need to know the cost from x plus 1 and x plus 2 to the end of the staircase. This is where recursion comes into picture. So recursion just tells us to worry about the current step and the base case. We have to assume that the recursive method works and it correctly solves the remaining problems. Once we get the answer from for the remaining problems or the remaining subproblems, we just need to calculate the answer for our current step. Now this is exactly what we have done in our solution. So we are just assuming that we have the answer for going from x plus 1 to the end and x plus 2 to the end, and using those answers we have just calculated the answer for our current step. So let's quickly go through the recursive solution for this problem. So let's say that our helper method is responsible for returning the cost from a particular step to the end. So what we are doing, we are recursively calling this for x plus 1 and x plus 2. In this case, x is equivalent to I. So we are calculating the cost for going from a particular step to the end for the next two steps. And we assume that the recursive function is going to return us the correct answer for this subproblem. We do not have to worry about how, we just have to assume that this recursive method works for these subproblems. Now, once we have the answer for these subproblems, we are just finding the minimum of these two. So whatever is minimum, whichever cost is minimum, it is more profitable to go to that step and then move towards the end. So that is exactly what we are doing here. Out of the two possible costs, we are finding the minimum one, and then in that cost, we are adding the current steps cost. And by doing this, we come up with the total cost for going from this particular step to the end. And once we have come up with the total cost, we just return the answer from here. Again, the base case is once we have reached the end. So once we have reached the end, we do not have to take any more steps or pay any more cost. So once we are at the end, so what is the cost of going to the end? We are already there. We do not have to take any step. So the cost will be zero. So in this base case, when we have already reached the end, we simply return zero. And then we have called this helper method with the initial input. So the problem statement states that we can either start from step 0 or we can start from step 1. So whichever step gives us the minimum cost, that will be our final answer. So that is what we have returned from here. But as expected, this solution gives a time limit exceeded error. So let's draw a tree and try to analyze. So let's draw a tree for n equal to 5. So for n equal to 5, we start from step 0. For step 0, we have two possibilities. We can go to step 1 or we can go to step 2. From 1, we have two possibilities, again 2 and then 3. From 3, we have two possibilities, 4 or 5. From 4, again, we just have one possibility, which is 5. From 2, we have two possibilities again, 3, 4. Then from 3, we'll have two possibilities. From 4, we'll have one possibility. Here again, for 2, this complete tree will be replicated here. So we can clearly see that we have the problem of overlapping subproblems. We are calculating the same subproblem again and again. So for 2, we'll be calculating this problem here. We'll be again calculating the answer for the same subproblem here. For 4 also we are calculating it multiple times. For 3 also we are going to calculate it multiple times. So it is very obvious that we have the problem of overlapping subproblems. The only difference between this problem and practice problem 1 is that we can see optimal substructure as well here. So if we can find the minimum or the best answer for the two subproblems, then using those minimal answers for those two subproblems, we can find the most optimal or the minimum answer for the current problem as well. So the minimum answer for the current step depends on the optimal answer for both the subproblems. So that's why we can also see optimal substructure here. So as earlier, again, our first improvement would be to add memoization. So if we store the answer for a problem in a map, then we do not have to solve the problem again. And as we have already seen, to store the answer for a particular problem, it's really easy. We just need to make a map and store the answer for the problem. So that's what we have done. In our recursive solution only, we have declared a map. So first of all, we calculate the answer for the current step using recursion. So the logic for calculating the answer recursively is exactly same as we discussed in our recursive solution. Now, once we have found the answer for the current step, one extra thing that we are doing here is that we are making an entry in the map. We are storing that for this subproblem, this is the answer so that we do not have to solve this subproblem again. And we are returning the current answer. Now we have the base case, which is exactly same as the recursive solution. Apart from that, we also have another condition wherein we are checking if we have already solved this subproblem or not. If we have already solved this subproblem, there will be an entry for it in the map. So we return the answer directly from there instead of again solving it recursively. If it's not solved, then we'll come to the recursive step and we'll solve the problem recursively. And again, we are calling this helper method, and we have two options. We can either start from 0 or 1. So this is the memoized solution, and obviously this solution gets accepted on Leetcode. Now let's try to write the recurrence relation for this problem. So let's say that f is the function which returns the total cost of going from a particular step to the end. So f of n is nothing but minimum of f of n plus 1, comma f of n plus 2 plus cost of n. So this is the recursive relation for this problem. Now again, we can clearly see that this can be modeled using a one-dimensional array. Each cell in the array is going to represent the minimum cost of reaching the end from that cell. So let's quickly go through the tabulation solution. So as discussed, we are declaring a DP or a helper array of same size as the cost array. Now in this particular solution, the base cases are going to be the last cell and the second last cell. Because when we are at the last cell, we'll just pay the cost of that cell and jump to the end. And when we are at the second last cell, again, the most optimal answer would be to pay the cost for that cell and take two steps and directly jump to the end, because the other option is we pay the cost for that cell, jump to the last cell, then again we would have to pay the cost of that last cell. So it makes sense to just pay the cost of the second last cell and make two jumps to directly reach the end. So these two are going to be the base cases. Now we are going to fill this array in a reverse order. So again, dp of I will depend on the cost of reaching the end from the next two cells. So that we have already calculated, and using those two answers or those two optimal solutions, we'll just calculate the cost for the current cell. And that's how we'll keep filling it step by step from the reverse. And what would be the final answer? The final answer would be the value stored in cell with index 0 or cell with index 1. That is because the value stored in index 0 is the cost of going from 0 to the end, the minimum cost, and the value stored in index 1 is the minimum cost of going from the first index to the end. And as it is given in the question, we can either start from 0 or 1 based on whichever gives the minimum cost. So that is why we just check that what is the minimum out of these two values, and that is going to be our final answer. The time complexity for DP is also very similar to problem 1. In tabulation, we are just filling an array of size of the order of n. Thus, the space and time complexity is simply big O of n. Even for memoization, we are solving n plus 1 distinct problems. So we are solving the subproblems for 0, 1, 2 till n. So we are solving n plus 1 distinct problems, and memoization makes sure that we solve each subproblem only once. So we are solving n plus 1 different problems, and each problem takes over time for being calculated, because we just need to take the minimum and add the current cost, which is a O of constant step. So the total time complexity for the memoization solution is again big O of n. Hope the solution and logic is clear now. In case if you have any queries, feel free to mention in the comment section and I'll try to help you there. And also see you in the next video. Thanks. Bye bye.